Hello, Krishna. Am I audible?
Hello, sir. Good evening. Yes, I heard.
Good evening. Everything good?
Yes, sir.
All right. Any doubts from the last class?
No, sir.
All right. So let's wait a few minutes for the students to come. Then we'll start the class.
Sir, can you show the last question?
Last question is this one. You have to prove dy upon dx equals to sine square a plus y upon sine n.
Okay, sir.
All right. Let's start. All right. So today what we are going to do, differentiation of a function of a function. All right, Krishna. This is a new topic for today. Krishna, am I audible?
Yes, sir.
All right. So first, let's understand what function of a function means. Function of a function means composite function. And what is composite function? If I have f of x as suppose x square and g of x as sine x. All right. If I write sine of x square, then what I did here, I wrote g of f of x, right? Suppose I say, what is g of 1? What will you do?
1 power whole square. 1. Oh,
G of
sine
1,
1. Sine 1.
sine 1. If I say g of 2,
Sine 2.
g of 3,
Sine 3.
sine 3. So g of f of x, what will happen? Instead of x, we'll put x square,
Yes, sir.
right? So that is why we get sine of x square. Now what happened here is the output of x square, right? If I ask you g of f of 1, then first you have to calculate f of 1, right? So you'll put f of 1 as 1 square. So 1 square is 1. 1 is the output of f of 1, and that becomes the input of g of x, right?
Yes, sir.
So this will be g of 1. So this is sine of 1 square, that is sine of 1. This is clear. This is called composite function. All right.
Yes, sir.
Sometimes we write this as g of f, or if I have to write f of g of x, then I write f of g. All right. This is called composite function. Now how to differentiate this one? We know the differentiation of sine x. Differentiation of sine x is cos x, right? This is very simple standard formula. But if I say this function, differentiation of sine x square, now we know the differentiation of sine x upon dx, right? Differentiating x with respect to dx, that is okay for us. But here the function is x square. So what we can do here, we can write this is differentiation of sine x square with respect to differentiation of x square into differentiation of x square with respect to x. Is this steps clear?
So, sir, the function inside f of x, you wrote it down. I
Right.
mean, yeah.
Right. I am taking one way to understand this is I'm taking this thing t. Suppose I take this t, and this becomes sine t. So I cannot differentiate sine t with respect to x. So what I have to do, I have to differentiate with respect to t. But because I replaced the x with t, then I have to differentiate t also. Right? Suppose let me write it down. Suppose I take x square as t. All right. Don't write like this. I'm just assuming. So this becomes d sine t upon dx. But I cannot differentiate t with respect to x. So what I can do, differentiation of sine t with respect to dt, but then I have to differentiate t with respect to x also. Now we can just replace the value. So d sine x square upon dx square into dx square upon dx. This is clear?
Yes, sir.
All right. Now what will be differentiation of d sine x square upon dx square? This will be cos x square. Right? Because this is sine t upon dt, and that is cos t. We don't care what function is inside this sign. But now we'll multiply this with differentiation of x square, that is 2x. So this is the final differentiation of sine x square. This is clear?
Yes, sir.
Please note it down.
Done, sir.
All right, solve this question. Y equals to tan x raised to the power 5. All right, find dy by dx.
Done, sir.
All right, how we can solve this?
So differentiate tan x power 5 with respect to x power 5 and, and multiply it with x power 5 d by dx of x power 5.
So this is
Sec square x power 5 into 5x power 4.
absolutely right. So this is clear, right? No issues here. So always notice this, that if the function is composite or not, right? Whenever the function is composite, we have to solve till the end, right? So let's solve another question. Y equals to e raised to the power x raised to the power 4. All right, this is not 4x, this is x raised to the power 4.
Done, sir.
All right, how to solve this one?
D by dx power 4 of e power x power 4.
Differentiation of e raised to the power x raised to the power 4. Now what should I write here?
Dx power 4.
Dx raised to the power 4. And multiplication by,
Dx power 4 by dx.
right? So what is the answer here?
E raised to x to the power 4 into 4x cube.
Absolutely. All right. So next question. Y equals to log of x raised to the power 5.
Done, sir.
All right. So here dy by dx equals to differentiation of this upon this into differentiation of this with respect to dx, right?
Yes, sir.
So what should I write here?
1 by x power 5
Right,
into
5.
5x power 4.
The final answer is 5 upon
5x.
x. Let's see this question. Y equals to sine e raised to the power x raised to the power 5.
So here we should do it 3 times, right?
I don't know. Think about this, Krishna, right? But yes, you have to do this 3 times, right? Because see, always look for how many functions are there. First, there is sine, right? Now we know the differentiation of sine x. But here, instead of x, we have e raised to the power some function. So we
Yes,
have
sir.
to differentiate according. Then instead of e raised to the power x, we have another function. So this is g of f of p of x, right?
Yes, sir.
So please solve.
Done, sir.
All right. So here, how we can do this? We can write dy upon dx equals to differentiation of sine of e raised to the power x raised to the power 5 upon this into differentiation of e raised to the power x raised to the 5 upon differentiation with respect to this into dx raised to the 5 upon dx, right?
Yes, sir.
So this is cos of e raised to the power x raised to the 5 into e raised to the power x raised to the 5 into 5x raised to the power 4. No doubts?
No, sir.
All right. So see, this thing here is called chain rule. If we have a function inside a function inside a function inside a function, right? So to differentiate that, we use chain rule. You can see there is a chain like this. Yes or no, Krishna?
Yes, sir.
That is why this is called a chain rule. Now, if you want to solve these questions more easily, so what you can do, start from the right. All right, start from the right. What function you see first? Sine. So differentiation of sine x is cos x. So just write cos whatever inside sine is. Now this sine is gone. Now moving forward, what function you see? E raised to the power x. So e raised to the power x differentiation is same. Now this e is also gone. What function you see? X raised to the power 5. So that is 5x raised to the power 4. So this way you can solve this without writing a lot. All right, Krishna?
Yes, sir.
So This is very important. This is called chain rule. All right, you will need this a lot. So let's move on. More questions on this. So now I want you to first try by this method, then this method. All right.
Okay, sir.
This one you have to solve. Hello, Syed. I'm audible.
Done, sir.
All right. So you used both the methods.
Yes, sir.
So this method is clear to you, the last one.
Yes, sir.
So what we can do, I can write the answer directly also. Dy by dx is now e raised to the power sine x raised to the power 4 into cos of x raised to the power 4 into 4x cubed, right?
Yes.
All right. Now, please write down this method also for these questions in your school examinations. All right.
Okay, sir.
Next question on this. Y equals to log of e tan x raised to the power 5.
So we should use both the methods.
Yes. For practice, you can use both the methods. First, try this method, direct one, then the longer one. All right.
Done, sir.
All right. So what will be the answer here? We have dy by dx equals to 1 upon e raised to the power 10 x raised to the power 5 e raised to the power 10 x raised to the power 5 into x square x raised to the power 5 into 5 x raised to the power 4. Right, Krishna?
Yes, sir.
No issues here?
So first two terms get cancelled.
Right. They will be cancelled and this will be the final answer. Okay. And Shikhani, Syed, am I audible?
Yes, sir.
All right. We are doing differentiation of function of a function and you missed this class and this is very important. So let me go ahead or backwards and explain what this is. All right, quick review. Composite function, if you have to write function of a function, right? Suppose we have a function x square, another function sine x. If I write instead of x, x square, then I can say this is g of f of x, right? Instead of x, I'm putting f of x. So this is called composite function. This is clear or not clear?
Yes, sir. Clear.
Right. So how to differentiate composite functions? If we have to differentiate tan of, or let's take this function, differentiation of sine x square. We know the differentiation of sine x, not sine x square. So what we can do, differentiate sine x square with respect to dx square into dx square differentiation with respect to x. So differentiation of sine x square is cos x square into differentiation of x square is 2x. So the final answer will be cos x square into 2x. Same way we can differentiate y equals to tan x raised to the power 5 by first differentiating this with respect to x raised to the power 5 into differentiation of x raised to the power 5 with respect to dx, and which is sec square x raised to the power 5 into 5x raised to the power 4. This is clear, everyone? Shikhani, Syed, this is clear?
Yes, sir.
All right. So this type of questions we can solve directly also. Let's solve this question. Let me just log of sine of cos of x. All right. Log of sine of cos of x. Find dy by dx. And you can see these functions are not multiplied. Instead of sine x, I have sine of cos x. And instead of log x, I have log of sine of cos x. So please try to differentiate this.
Done, sir.
All right. Syed and Shikani, you have solved this?
Yes, sir.
All right. Shikani, what about you? So what we can do here, dy by dx is differentiation of log of sine of cos x with respect to differentiation of sine of cos x into, give me a minute only. All right. Now differentiation of sine of cos x with respect to differentiation of cos x into differentiation of cos x with respect to x. So this will be 1 upon sine of cos of x into cos of x into minus sin x. This is clear, everyone?
Yes, sir.
All right. Syed, this is clear?
Yes, sir.
All right. So this is called chain rule. All right. Chain rule, very, very important thing. So let me give you a question on the basis of this, and I'll give you 5 minutes for that to solve. If f of x equals to under root x square plus 1, g of x equals to x plus 1 upon x square plus 1, and h of x equals to 2x minus 3, and find f dash h dash g dash x. All right, this is the question. The question is clear to everyone?
Yes, sir.
All right, take your time, solve this. Anyone has solved this? Krishna, Syed, Shikani.
So I have differentiated separately, but not able to find the exact answer.
All right. So you are solving it, right?
No, sir, I can't find the way to solve this.
All right. All right. Let's see. So we need f dash, h dash, g dash. So let's first find f dash. X is 1 upon 2 root x square plus 1 into 2x, right? This is clear to everyone, the function differentiation of f of x. So 2 and 2 is cancelled. So we have x upon under root x square plus 1. Now g dash x will be x square plus 1 into differentiation of this is 1 minus x plus 1 into differentiation of this is 2x upon x square plus 1. So this is x square plus 1 minus 2x square minus 2x upon x square plus 1. So this is 1 minus x square minus 2x upon x square plus 1. This is clear, Krishna?
Sir, is it x square plus 1 the whole square?
Sorry, yes, this is whole square. Absolutely right.
Sir, I didn't get the first one, sir. So I
This
got it
one?
as x cube plus x.
Let's see. F of x we have under root x square plus 1. So this is, I can write 1 plus x square to the power half, right?
Yes, sir.
Now, how do you want to solve this? Like, how did you solve this?
So first I differentiated the outer one, like half into x square plus 1 into d by dx of x square plus 1, like that.
Right. So f dash x will be differentiation of 1 plus x square half with respect to 1 plus x square. Now we have to differentiate 1 plus x square with respect to x, right?
Yes, sir.
So what is the differentiation of this?
Oh, yes, sir, I made a mistake. Half into 1 plus x square minus half.
Minus half. So this is minus half into this is 2x. All right. So minus half means 1 upon under root 1 plus x square.
Yes, sir.
Right. So now we have h of x h dash x will be 2, right?
Yes, sir.
All right, Said, Shikani, this is clear till now?
Yes, sir.
All right. Now what the question is saying, f of g of x or what? All right, f of f dash h dash g dash x, right? Let's see. See, this is g dash x, right? The question says we have to find this. That means you have to put the input as g dash x when finding h dash x, right? If I ask you what is h dash 1, what will you do? You'll put 1 instead of this. So this will be 2 again because there is no function of x here. This is a constant function. So h dash 2 also will be 2. H dash 3 also will be 2. Now if I write h dash g dash x, then again this will be 2 because this is a constant function. Yes or no, Krishna?
Yes, sir.
So this we have already got as 2. So I can replace the value here. So this is f dash 2. Now you can put this value in here. So we have 2 upon 2 square plus 1. So 5. This is the answer. All right. Or you can rationalize 2 root 5 upon 5. All right.
Yes, sir.
So always when solving questions like this, always start from inside. First simplify this, then put the value, then find this, then put the value, find this. But when differentiating in chain rule, always start from outside. All right.
Okay, sir.
So please note it down.
Done, sir.
All right. Next question. If ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0, find dy by dx and dx by dy. Also show that dy by dx times dx by dy equals to 1. All right. And don't try to cancel this like this. All right. Don't cancel like dx and dy is cancelled. No, not do that. Right? Because d upon dx is a function in total. All right. So please find dy by dx, dx by dy, then multiply, see what you get. Question is clear, all of you?
Yes, sir.
All right.
So the second last term is 2fy, right?
Second last to fy.
Sir, can you help solving this?
All right. Syed, have you tried solving this?
Sir, I'm not getting it.
Not getting it. All right. So let's just find dy by dx. And this will be 2x. I'm differentiating directly, all right? If you have any doubts anywhere, just ask. So this will be 2ax plus 2hy plus x dy by dx plus 2py dy by dx plus 2g plus 2f dy by dx equals to 0. This is clear to everyone?
Yes, sir.
Okay, let's simplify a bit. So dy by dx equals to, again keep the dy by dx terms together. So this will be 2ax plus 2hy plus 2g. I'm taking this 2g together here plus 2hx dy by dx plus 2py dy by dx plus 2f dy by dx. Again, we can write dy by dx. Let's bring all of this to this side. So this will be 2hx dy by dx minus 2py dy by dx minus 2f dy by dx equals to 2ax plus 2hy plus 2g. All right, now you can take common and put it to this side. So dy by dx is equals to 2ax plus 2hy plus 2g whole divided by 1 minus 2hx minus 2py minus 2f. Yes or no? This is your answer.
Yes, sir.
All right, Syed.
Yes, sir.
All right. Now dx by dy. How to find dx by dy? You cannot just reverse this, right? If you guys did that, then that would be wrong, because I again told you d upon dy will be a function here, right? This is an operator, so you cannot just reverse this and find the answer. So Krishna, can you read me the equation that was given? Ax square 1.
Yes, sir. Ax square plus
All right.
2h.
Slowly. So ax square, that means 2ax dx upon dy will be the differentiation, right?
Yes, sir.
Then after the second term is
2hxy.
2hxy. So 2hx will be dx upon dy y plus x. All right. Next term
By square.
by square 2by. Next term
2yx.
2
Yx.
2xy, that you mean.
Yes, sir.
Then did I do something wrong here? This is 2gx, right, Krishna? Not 2yx. 2gx.
Okay, sir.
So we have 2g dx upon dy. Okay, next term
2fy.
so 2f, and next term is c.
Yes, sir.
So this will be equals to this one. All right, I think I did another mistake here. This is
Yes,
given
sir.
as 0, right, in the equation?
Fy, right?
Sorry.
Sir, isn't it 2fy?
Yes, but we are differentiating dx upon dy. So 2fy will be differentiated to f, right? Because differentiation of y with respect to y is 0. Did we have equation as equals to 0? All right. So I
Yes.
committed a mistake here. I wrote y equals to that, right? So that is a mistake. So I did not look the equation correctly. So this is 0. You cannot take this and find common. This line is wrong. Right? You have to put this equals to 0 and find dy by dx. Right? You guys see what I did, what mistake I did there?
So can you explain again?
Right. See, we had the equation as this is equal to 0. So I can just directly differentiate this and then find dy by dx. But what I did is I differentiated, right? Assuming that this is equal to y, right? Actually, I have my video here on the right side, so I could not see this 0. So what I thought is this is the function. So I differentiated dy. So I wrote dy by dx here also. But here this is equal to 0, right? They have given you this equation is equal to 0. So differentiation of 0 is again 0. So this dy by dx will not be there in this equation. Is this clear?
Yes, sir.
So that I did a wrong thing. So again, we can find dy by dx from here. Let's keep this together, put them here. So we have dy by dx equals to minus 2ax plus 2hy plus 2g upon 2hx plus 2by plus 2f. All right, this will be the answer here. Will not be getting 1 there. All right, and from here we can find dx by dy. Again, this is 0. So we have 0 equals to 2ax dx by dy plus 2hy dx by dy plus 2hx plus 2by 2g dx by dy plus 2f. All right. So here dx by dy equals to, we have minus of 2hx plus 2by plus 2f whole divided by 2ax plus 2hy plus 2g, right?
Sir,
I
I
hope
didn't
this
get
is
it,
clear.
sir.
All right. Actually, what is happening, I can see. Actually, I don't have the equation in the board, right? Let me think how we can show. Let me write this equation here. All right, the equation is ax square plus 2hxy plus py square plus 2fx plus 2gy plus c equals to 0, right? You can look at the constants, but I think this is the equation. Now, when I differentiated this in place of Krishna, do you want me to differentiate this again? This dx by dy.
Yes, sir.
All right. So tell me if the equation is wrong anywhere. Ax square plus 2hxy plus py square plus 2fx plus 2gy plus c equals to 0. This is the equation.
No, sir. Plus 2gx plus 2fy.
2gx 2fy. All right. So we can differentiate this with respect to y. Right. This you have to notice. We are differentiating with respect to y. So if I write this 2ax dx by dy, this is clear.
Yes, sir.
Plus 2h. Now we are going to use UP form. So let's differentiate y first. So differentiation of y with respect to y is 1. So x plus y dx upon dy. Yes or no?
Yes, sir.
Plus 2by. This is clear.
Yes.
Plus 2g dx upon dy. Right?
Yes, sir.
Plus 2f equals to 0. Right?
Yes, sir.
Now let's just open this bracket. So 2ax dx by dy plus 2hx plus 2hy dx by dy plus 2by plus 2g dx by dy plus 2f equals to 0. Let's take all the dx by dy together. So dx upon dy, taking common from here, here and here, we have 2ax plus 2hy plus 2g. And I'm putting all of this to the right hand side. So taking negative common, 2hx plus 2by plus 2f. Right, Krishna, this is clear till now?
Yes, sir.
Now we can see dx upon dy equals to minus 2hx plus 2by plus 2f whole divided by 2ax plus 2hy plus 2g. This is clear?
Yes, sir. So, sir, you're differentiating on the basis of dx by dy, right?
Yes. All right, first I differentiated with respect to x also. Please note it down first, then I'll go back. You can see how differentiated, or I can differentiate again. All right, first note it down this. Syed, this is clear? Syed, Shikani, this is clear?
Yes, sir.
All right, these are what 4-5 marks questions. All right, long questions, and you have to be a bit careful when differentiating. Done, Krishna?
Done, sir. So, but why did you keep dx by dy at the first term, sir?
Uh, what do you mean by as first term?
So, in the second step, ax square while differentiating that.
Ax square, because I'm differentiating with respect to y, right? So ax square, what will happen? A differentiation of x square with respect to y. Now again, I cannot differentiate this with respect to y. So what I have to do? A dx square dx into dx upon dy. So this becomes 2x into dx upon dy. All
Okay.
right.
Okay, sir.
So this is done.
Done, sir.
So let's try to find dy upon dx. Again, let's write the equation. Or you guys want to try that first? Should I differentiate again, or you guys want to go first dy by dx? Krishna, Said.
So we'll do it first.
All right. You have to do this exactly similar way, right? Just look at you are differentiating with respect to x. So in terms of x, you can differentiate directly. In terms of y, you have to multiply with dy by dx also. That keep in mind. I'm trying to find.
Done, sir.
All right. So you got the answer here, Krishna?
Yes, sir.
So the final also dx upon dy into dy upon dx equals to 1.
Yes, sir.
All right. Syed, what about you?
Yes, sir.
All right. So no need for me to solve this anymore, or should I go and solve this?
No need, sir.
No need. All right. Thank God. Right. I have been solving this 3 times now. All right. Next question. Let's start with differentiation of inverse trigonometric function. All right. Differentiation of inverse trigonometric function. First formula, differentiation of, here we have function and its differentiation. Sine inverse x, the differentiation is 1 upon 1 minus x square under root. We have cos inverse x, and that is negative of 1 minus x square. We have tan x, and this is 1 upon 1 plus x square. Cot x, this is inverse, minus 1 upon x square. And you have to remember these formulas, otherwise very difficult to solve questions for you. 1 upon cot x under root x square minus 2. Write it down, the formulas.
Done, sir.
All right, let's see the proof of this. Again, whatever we did in inverse trigonometric functions, same way we can prove this. Let sine inverse x be theta, then we can write sine theta is x. Now let's differentiate with respect to x. We'll get cos theta d theta upon dx will be 1. So we can say d theta upon dx equals to 1 upon cos theta, right?
Yes,
So
sir.
this is d theta upon dx is 1 upon cos theta. I can write 1 minus sine square theta under root. Right? The first identity we have ever studied in trigonometry, 1 minus sine square theta upon under root. So this 1 upon 1 minus sine theta is x, so I can write x square. And instead of theta, I can write sine inverse x. So this is differentiation of sine inverse x upon dx equals to 1 upon 1 minus x square under root. All right, this is the proof. This is the way you can prove all of those. Please try that at home. All right, to prove this, because they may ask you questions on this, right?
So
This is
d by
clear,
dx of sine theta is just cos theta, right?
right? So I wrote this sine theta is cos theta.
So then d theta by dx.
Again, Krishna, see, I have to differentiate sine theta with respect to x, but I cannot do that directly. What I can do, d theta into d theta by dx, right? I can differentiate sine theta with respect to theta, right?
Yes, sir.
Clear? Syed, Shekhani, this is clear? Proof?
Yes, sir.
All right, note it down. And the formulas are also very important, so please memorize them.
Done, sir.
All right, solve this question then. Cos inverse 2x. Y equals to this. Find dy by dx. All right, try to solve this.
So just move the minus 1 by root 1 minus 2x the whole square, right?
Shekhani, your voice is not audible that much. It's not clear. Can you repeat the question?
So 1 minute, I'll send in chat.
All right.
Done, sir.
All right. Shikani, let me just solve this. All right. Then you can ask me if you still have that doubt. So we can write. All right. I got you to the into 2, right? Absolutely right. But you missed 1, 2 also. Let me explain. See, again, you have to use chain rule here because we do not have cos inverse x. We have cos inverse 2x. So differentiation of this, we can write this is differentiation of cos inverse 2x upon differentiation of with respect to 2x. Then differentiation of 2x with respect to x. This is clear or not?
Yes, sir.
Right, Shikani? Shikhani, this is clear?
Yes, sir.
So now you can use the formula. This is 1 minus x square. Now x square, instead of x square we have 2x. That means 4x square, right? 2x whole square and a negative sign. Now we have, this is 2. So we have minus 2 upon 1 minus 4 x square in the root. This is clear or not, everyone?
Yes, sir.
All right, Said.
Yes, sir.
All right, next question. Tan inverse x square. I need to solve this one.
Done, sir.
Sir, 1 minute.
All right.
Sir, is my answer correct?
Yes, Shikhani, this is absolutely correct. All right, let me solve this. So what we can do here, this is differentiation of this 1 upon x square, x raised to the power 4 into differentiation of x square is 2x. So 2x upon 1 plus x raised to the power 4. Any doubts in this?
No, sir.
All right. Next question on this. Sec inverse under root x.
Done, sir.
All right.
Sir, one more.
All right, Shivam.
Sir, sent. Sir, is it correct?
Let me check. 1 upon root x square minus x. Now the formula is root x square minus 1, right? And mod x also. Shekhani, actually, I'm not able to. Did you multiply the x inside the under root, or what did you do?
Yes, I did that.
But then again, there is something wrong. Let me solve this. dy by dx. So this is differentiation of sec inverse under root x with respect to under root x into differentiation of under root x with respect to x. So here we have 1 upon mod under root x into x square minus 1. So x minus 1 into this is 1 upon 2 root x. So see, mod under root x is under root x only. So under root x into under root x is x. So we have 1 upon 2x under root x minus 1. This is clear?
Sir, what is the formula for finding the derivative of the root?
You don't have to use formula. I remember that, but it's good if you remember also. We can write under root x as x raised to the power half. So now we can say half into x into half minus 1. So this is half x raised to the power minus half. So this is half under root x. So root x differentiation becomes 1 upon 2 root x. All right. This is clear. Syed, Shekhani, Krishna.
Yes, sir.
Yes, sir, clear.
All right. Another question. Y equals to sine inverse 2x upon 1 plus x square. All right. Try to solve this one. Find dy by dx. solve this?
Yes, sir.
All right, how we can solve this, Krishna?
Sir, first we differentiate d by sine inverse 2x by 1 plus x square with respect to 2x by 1 plus x square. Then multiply it like chain rule we have to do.
Absolutely, but that you can see must have been very long question, right? Long process.
Yes, sir.
What we can do, we can use our knowledge of inverse trigonometric functions in here, right? How? If you put x equals to sine inverse, put sine inverse x is equals to theta, suppose, or just put x equals to tan theta. All right, x equals to tan theta. So what this becomes, if you remember the formula, 2 tan theta upon 1 plus tan square theta is sine 2 theta. Remember this
Yes, sir.
formula? So I can use this whole as sine 2 theta. So y becomes sine inverse sine 2 theta, and this is 2 theta. And what is theta? Theta again we can write 2 tan inverse x. So if you remember, we had a direct formula for this. 2 tan inverse x is sine inverse 2x plus 1, है ना? 2x upon 1 plus x square, right?
Yes, sir.
So we have y equals to tan inverse 2 tan inverse x. Now we can differentiate very easily. dy by dx is 2 times 1 upon 1 plus x square. This is the answer. All right. Yes,
Yes,
or
sir.
no, everyone?
Yes, sir.
Syed, Shekhani.
Yes, sir.
All right. So no doubts here.
So I differentiated the first method. I got something else.
All right. You did not get something else. If you simplify that further, you will absolutely get this value. But that will be a very long process. So whenever you see inverse trigonometric questions and some very complicated functions, this you have to use inverse trigonometric formulas. Don't just try to solve by differentiating. All right.
Okay, sir.
So for this, you have to use your you have to be good at inverse trigo also. All right. So this is all for today's class. You will be getting assignments also. All right. Any doubts in today's class?
No, sir.
All right. See you in the next class, guys. Take care.
Thank you, sir.
All right.
Thank you, sir.
Thank you, sir.
All right.